Hello, hi, welcome to the chat, welcome to the stream. Okay, so there was a short problem in the last stream in part 6. Yeah, so I had to quickly stop it in between, and then now we are with part 7. Okay, so I actually kind of completed 8 on my side, but it didn't appear on the stream because it got disrupted. So I'll do 8 again. Okay, so eighth question, I'll go through it once again. uh, i I have, oh, by the way, for housekeeping, for those who are coming to the stream for the first time, the problem question is already in the description. You can check the GitHub link and clone the code and do it with me, or you can just watch the stream. Okay, so let's move in. So eighth question in the third level 3 difficulty: transform a list of numbers into their cumulative sum. Okay, so they have given 1 2 3 4 as the input, sample input, and the sample output is the cumulative sum, as in I'll explain it. Okay, so here they have this, given this as the input, right? This is the question. Now what they want is an output where the first element of the output list will be that one itself. Okay, and the second element will be this 1 plus 2, okay, which will become 3, and the third element will be 1 plus 2 plus 3, which will become 6. Yeah, and the fourth element will be, add the other one also, so 1 plus 2 plus 3 plus 4, which becomes 10. Okay, so they want this, went into erasure mode, just a second. Okay, so they want this 1 3 6 10 as the output. Okay, so they want an output result which will show this. Okay, so this is kind of a running sum. So in part 2 or something, we already saw a running average. So this is just one step, one small change. Instead of average, we'll be finding the sum. Okay, so how can we do this? Using streams. So we solved a similar one for mean. Yes, correct. So we solved a similar one for average or mean. Okay, so how we do this, how we can approach this is, there is this thing called limit, right, in streams. So using limit, what we can do is we can limit the thing which we are summing. So if we say limit of 1, it limits to the first item. If we say limit of 2, it limits to the first 2 items. Okay, so it's not up to number 2. So let's say I give you an array of say 5 9 15 and then 25. Okay, so limit of let's say 3, which will give these 3 items, 5 9 and 15. Okay, so that will be the limit of 3. So what they're essentially asking is to limit by a number. So we start with limit 1. Okay, limit of 1 up to limit of the length of the full array. So for us, the input question is 4, size 4, right? So for us, it will be limit of n, which is equal to 4 in our case. So when we iterate over this and find the sum of each limit, we will get the final answer. Okay, so there might be optimized ways to do this. For example, there is this pre-increment, post-increment, those kind of operations, right, which we do for competitive programming and things like that. But here we are just looking into streams alone, so we will just use the streams API to find the answer. Okay, so let's start. We will have to start with an int string, right? Int string. Okay, what did I do? Okay, int stream dot range. So there is this thing called range and range close. So we check this in very detail in that first stream. Okay, so I'll just give a recap here. So range will actually start, it takes 2 arguments. The first argument is the starting number. The second argument is n minus 1. It doesn't take the, it excludes the end range. So that is one. And the other one is range closed, which means it will take the start number and also the end number. Okay, so in this case we have to go from 1 to the size of the list, right? So which means we need to have both. So let's say, okay, so let's say I gave here 1 comma 4. It means it takes counts from all the numbers 1 to 4. Okay, if I had taken just range, it will count from 1 to 3 only. It will ignore 4. Okay, so that's the example. So instead of hard coding 4 here, we'll do numbers dot size. Okay, this will take all of the 4. Second argument included in closed. Correct. Okay, now we have a stream of numbers. Okay, so what we'll do is for each number we will do map. Okay, and in the map, let me write this neatly. Okay, and in the map what we'll do is we'll get the number, right? So you'll get some number. Let's call it I, because this is like we are running a for loop in which we usually use I, right? So this is kind of like the I which we use in the normal iteration. And for each number what we are going to do is we are going to take numbers. Okay, we are going to take the input numbers, then we are going to do a stream on that input, and then we are going to limit it to the I that we got, right? And then we are going to sum. But what happens? There is no sum function here. So can you say how we'll get the sum function here? Right, int stream. So numbers is a integer, list of integer, right? So we have to actually map it to an int stream. So you do stream and then you do dot map to int. Okay, and then what you say integer value of, which means that it will each entity in this stream will be an integer. Okay, so let me expand that also to make it look better. Numbers dot stream dot map to int dot limit dot sum. Okay, so you can see once I make it an int stream, on that int stream I got the sum function. Okay, so all of these basics we already saw in the level 1, level 2s, right? So we have mapped each of these to the sum of the respective limits, right? Now what we have to do, we have to finally collect it, and to finally collect it we just do dot to list, which doesn't work. Can you guess why? This is also from one of the previous examples, or like the previous levels. So I want list of integers result equals to this, right? So how do I get this? Okay, so I'll explain that. So since we did a int stream, it gives a oops, I went up by mistake. Okay, so it gives a primitive kind of, yeah, yeah. So I can understand you forgot. So it gives a primitive kind of integer, data type. Okay, so let me show that. So the int stream gives a primitive int. We have to convert it into capital integer, like the wrapper class, right? To do this, you need to this process itself in Java is called as boxing, right? Boxing and unboxing. So on stream there is a function on primitive types called as boxed. So you have to call that boxed function. Okay, so what will happen is you have to do dot boxed. Okay, so once you boxed it, yep, it will give you the APIs that are more easy, more compatible with collection. So you will get to list here. Okay, fine. So if you didn't box, it will be a little complicated, but since there is a out of the box function for this, we can simply do dot boxed and then dot to list. Okay, we got the result. Let's run it and see. Once we see that, I will go through it once again. Okay, so open call hierarchy. Okay, cumulative sum. There are two test cases. Let me run this test case first. JUnit test. Yep, that passed. And test cumulative sum 2 is another test case. Let me run this. That also passed. Okay, so in essence, what did we do just now? Okay, so we needed to, so if you see on a higher picture, so let's do a reverse engineering now. Okay, so we needed to limit each of the stream to some n number, which was, in here we saw that okay, in here we saw that n number is the limit that we want. Okay, so at first iteration I want first number, and second iteration I want two numbers, I need three numbers, four numbers, right? So I need an iterator kind of thing, like a for loop of, I'm saying I equal to 1 up to n. Okay, I need a for loop. So what can I do? That in streams itself there is a concept called range. Okay, range, closed, and ranged, these two are there in int stream. Okay, so once I get that stream of numbers, for each number what I'm doing is I am again creating a stream on the given input. Okay, so if you see, this is kind of, what is this? This is a big O of n square solution, I guess, because for each iteration you are going through the whole list. Correct. So this is a big of n square solution. So as I said, this is not the most optimized solution, right? But this is the solution for stream. Okay, so for each let me erase all this and this also. Okay, for each iteration, for each limit, so when the limit is 1, it goes through the whole of this. When limit is 2, it goes through all of this, so it takes 1 and 2 again. So when limit is 3, it takes 1, 2 and 3 again, right? The whole thing. When limit is 4, it takes 1, 2, 3, 4. So 4. So let's say there are a million items, it takes 1, 2, 3, 4 up to million. Okay, so 1, 2, 3, 4 up to million minus 1. So this is like so much operations going on, right? So for each of that stream, it generates a new stream for every iteration on these numbers, and it is doing a map to int. Why map to int? Because without map to int, you wouldn't get this sum handy function called sum. Okay, so this sum, average, these are all handy functions or like helper function which are there in this int stream. Now after you get an int stream, you want to collect it to a list. But since int stream is primitive, it wouldn't have this toList helper function. So we do a dot boxed. So when you do dot boxed, it converts some primitive to wrapper class, or like it boxes the data type, and then you do dot toList to get the final answer. Okay, so that was question number 8, 308, third level 3, question number 8. Okay, so if you guys have questions on this, let me know. I will slowly move to question number 9. Okay, so read through the questions, and read the question number 9 and try to understand it. This is the second last question for the day. Okay, so let's go through question number 9. So from employee data, identify which department has the highest average salary. Okay, so they have given some list of employees, and each employee has some department name, right? The classic employee problems. And they're asking which employee has the highest average salary. Okay, it's not just highest salary, it's the highest average salary. Okay, so let's go back to our whiteboard. And here we have two departments. There's HR department and there is IT department. Okay, and there are two employees in each department. Now their question is who has the highest average. So in HR, okay, there is one person with 60,000, I'll write 60k, and one person with 70k, right? By 2, whatever this is the average there. And for can it solve it? Good, 65k. Okay, Good thing iPad. And IT department, it has 80K plus, what is it, 90K divided by 2, okay, equals to whatever that value is. Please solve. I think it will take some time to solve. Ignore it, fine. So some number it gets. I think IT is the final answer. Regardless, let's do the math. 80 plus 90 by 2. 1,25,000. What? Oh, sorry. 80 plus 90 is 170 by 2. 170 by 2. So 85K. 85K. Okay. Now they want the answer that 85K is the final output, right? IT is the final output with higher average. That's it. Okay. So that is the gist of the question. Now, how to solve it? Okay. So first thing, okay, yeah. If you guys can come with some solution, let me know. And if you guys understood, if you misunderstood, I mean, if you didn't understand the question or something like that, even then let me know. I'll explain again. Okay, so this is also a classic two, you know, you have to do two. Should I do two? Let me think. Yeah, I have to do two levels of streams because you can't do this in one stream pass. So we are always trying to do one stream pass, but this problem you can't do in one stream pass because first you have to have a data structure which calculates the average, you know, going through all the employees and calculate the average in one stream. And then there should be one more stream which does the sorting and does the other operations for us. Okay, so what we'll do is we will do stream operation 1. Okay, so OP1, stream operation 1, what we'll do is we'll build a classic you know, department based grouping map. So in the map what we'll do is the string, and I think long is the long, no, it will be double, right, because it's average. So double, because decimal points are there in average, double. So this string will be the department name and the double will be the average. Okay, so we will store it in such a value. So what will be the final map for this? It will be like HR key and value will be 65. So let me write that, 65K. Similarly for IT, the value will be 85K. Okay, so you'll get a map like this first. Okay, now with this map you iterate over the, you know, entries of the map, and then you sort it by the value. Okay, and then get the first item and return back, find first. Okay, so simple to say. Let me also write OP2 here just for completeness. So OP2 will be you get the entry of the map. Okay, entry of key and values. Okay, you start a stream on it. Okay, and then on the stream what you do, you sort by value, right, because value is what has the average, and you do it reverse so that you get descending order because the highest should come on top, and then you do find first so that the topmost value comes back. Oh, but then you should also note that find first will give you the whole entry with like key and value. So from that you have to again do a map and get just the key and return it, because if you see they just want the name like IT, that's all they want. They need just a string, they don't need the full employee data or, you know, nothing like that. See, the output should just be IT, that's it. Okay, so let's do operation 1 first. So employees dot stream, okay, dot collect, and we have our classic grouping collector, okay, collectors dot grouping by, and we group by employee department, right? Department. Okay, so we collected it like that, but then we should also say that you have to average the values part. Okay, so let me write this neatly. Collect. Okay. Okay, so we said this is the key. Now we have to also say what to do with the value. Okay, so for the value, what we'll do is collectors dot average, averaging double, and what will we average? We will average the employee salary. Okay, I don't think you can do this here, right? So this is where we have the collecting and then function, right? So we have to downstream the employee lists and then do some work on it. Okay, or I think we can do this, can we? Yeah, we can do this. Okay, that was simple. I forgot that this thing existed. Okay, I'll explain this, what happened here. Okay, so what I'm saying here is you collect it into a map, right? That's what we saw here, right? Where is that? Right, we collect it into this map. Okay, and the map should have a key as string and double as, value as the double, which is the average. So what I'm saying here is key should be the employee department name. Okay, and I'm saying that the value should be the double of average the salary of the employees and give it as a double value. Okay, so now I can just write it, store it into a map. So map of string comma double of emp, let's say sal average. Okay, so we got this into a map. Fine, now we can do operation 2. So in operation 2, let's go. Operation 2 is take the map, then take its entry set. Okay, we saw how to do this entry set just in the previous stream. Okay, dot stream dot. Now what should we do first? We should sort it, and we should say how to sort it. Okay, so we shall say comparator dot comparing by, there will be a entry map dot entry dot comparing by value, right? So it already has this comparator inside the entry set itself, right? So it gives you a comparator comparing by value. Okay, and inside the comparing by value, I say comparator dot reverse order because I want the highest salary on top. Okay, so till now we have sorted it. Let me write this neatly. Okay, so I said that you have to sort it. How do you sort it? For every entry, compare its value and compare it in reverse order. So if you remember, I want 85,000 to go up, so I want like 85k and then 65k. Okay, my 8 looks very weird. So 85k and 65k, right? So it should be in descending order. So that's why I say comparator dot reverse, otherwise it will do in ascending order by default. Okay, so with that we got the sorted stream. Now what is the next thing we have to do? If I go back to our thing, we see that it has find first. Okay, so we get the first item out of the sort, right? And then we do mapping. So let's do find first dot find first. Okay, then you do dot map. Okay, and what do you want to map it to? You map map dot entry dot value. So there will be not dot, we need this get key. Okay, I'll say what that is also. Let me go here, go here. Okay, so what I'm doing here is I'm finding the first item after sorting, which will be the highest average salary department. Okay, and then I'm saying I want just the key part of it, because if you see, key is the department name in the map. Key is the department name like HR and IT, and I want this only like IT, which is the key. So I have to say in my function get only the key. Okay, so once I do this, what will be my output? Let me see. It's an optional string. Okay, so I do dot or else and say maybe empty string. Okay, so what I'm saying here is if it has a first value, it will be that whatever value it is. If it is not there, then I'm simply returning an empty string. Okay, so I'll store this in a string highest average salary department name equals this. Okay, and I return that. Okay, let me run this and come back to explaining the solution once again. Okay, there are two test cases. Let's run this test case first. Run as JUnit. Passed. Okay, where is the other test case? Let me enable word wrap. Yeah, this is the another test case. Right click, run as JUnit test. Passed. Okay, so both of them passed. Fine, so let me quickly go through what we did. So we did two operations. Okay, so operation 1, operation 2. So there were two streams created. The first stream was created, so you see the dot stream. The first stream was created to first of all map, get a map where the keys are the department names and the values are the average salary. Okay, so we created a map like this, which says HR. Okay, there are so many annotations here. Let me remove it. Okay, so we created a map which says HR and then its salary, average salary, IT, and then its average salary. Okay, so we created this map. That was the final output of operation 1. Then we went for operation 2. Okay, where is operation 2? This is operation 2. In operation 2, we created a stream of the entry set. So entry set is nothing but a set of each entry in the map. Okay, and when we streamed over that, we have to first of all sort it, because we need the highest average, right? So the highest average here is 85,000. Yeah, 85,000. Okay, so we got two values here, 65,000 and 85,000, out of which 85,000 is the highest average. So to do that, we need to sort it. Okay, now when you so we are still here in operation 2. Let me point it in our previous thing. Okay, so we did a sort, and we did a sort over the value part. Okay, so why the value? Because value is in the key value is what is having the average salary. Okay, so value is the average salary, and we did a reverse. Why reverse? In order to do a descending order sort. Okay, let me write correctly, descending order sort. Okay, fine. So we did a map.entry comparing by value. Okay, this is important. You compare values, not the key. Okay, because key will be the department names. You compare by value, and then you sort it in reverse order, so that the highest salary comes first, highest average salary comes first. Okay, and then you do find first to get the first item. Okay, you can either do dot find first or do dot limit of 1. Okay, both of them works, but I think dot limit of 1 does extra computation. I don't know, but since we have a help, handy function called find first, you do dot find first, and then find first will actually again return an entry only. Okay, so it'll, if you see it returns an entry of string of double. What we have to do is we need to map it, so that I don't want the whole entry, I just need the key part of it. And what is the key part? Key part is what our answer requires also. So you see here, let me use a different color. So you see here, okay, that was also not fine. Right, so the key part is the IT, right? Like the name of the department. This is what we want into the final answer, which is a string. Okay, so if you see, the return type of this function is also a string. They want a string as the output. So we say map the whole entry into just its key, and then it will return an optional string. right? So if you see, it returns an optional string. So why optional? Because if it couldn't find the highest salary because there aren't enough people or something like that, then it will not have a highest salary, it will return null. So in that case, we just say or else empty string. Okay, fine. So that was question number 9, and let's move to the last question. Okay, so read the question and try to understand it. Okay, fine. So let's go ahead. The question is to remove duplicate characters from a string while preserving its order, right? Preserving order, correct. So input is programming, output is programming in Ghetto language. Okay, so what they're asking is, they gave this string, okay, programming. They want an output where all the duplicate characters in this word should go away, right? So P is there once. Is it there anywhere else? No. Okay, so you got P. R is there once, I'll write R. O is there once, I'll write O. G is there once, I'll write G. R. No R. Okay, so it's doing this autocorrect thing. Okay, so R is already written here, right? R is already there here, so I don't want it again, so I'll not write R again. Okay, then you have A, then you have M. Okay, so M is already there here, so I'll not write it again. Then you have I and N, and then G is already there here, so I'll not write it again. So this is what they want. Okay, so it's programming, not programming. Oh yeah, it is programming. Okay, so that is what they want. Fine. How do we do this? Any ideas? If you guys have ideas, drop it in the chat. Okay, so let's see how we'll solve it. Okay, so what I'm thinking of is, we take a stream of the characters of the array, characters of the string. Okay, so if you convert this whole string into like let's say a character array. No, okay, no idea. Okay, so if we convert the whole, what is a string into a character array, then I can create a stream out of it, right? Because you can create streams out of arrays. So if I create a stream out of that array and then do a distinct, that's all I need to do, right? If I do a distinct, okay, in this I'll do a distinct. I mean, first I have to create a stream, okay, and on that I do a distinct. Okay, even now I have a small issue that they are still, yeah, 2 chars, correct. So if I do 2 chars, I'll get a character array. I'll actually get an int array. That is something we will look into. We'll get an int array, not a character array. And once you do that, you do a stream over that, and then you do a distinct over that, which will just give you program in. But then you still haven't accumulated it into a string. So to do that, what do you have next? You have a joining collector, right? Collectors dot joining. Okay, so when you do a joining collector, it will just join all the items in the stream. So it actually expects a delimiter. I'll not give any delimiter, which means it will just join everything together. Okay, is the approach clear? Shall we move ahead? Okay, so move ahead we will. Fine, so if you guys have questions, just drop it in between. Okay, so what we'll do, input dot chars. Is that what you meant? 2 chars. Is it 2 chars or chars? 2 chars. two character array will give a character. Okay, so let's say what happens with this. Okay, now if I go to, first of all, there is no stream on it. Okay, so there is no stream function. So if I cut this and do arrays dot stream, okay, hey, what happened? It went up for some reason. Okay, arrays dot stream. If I do input dot two char array, this will not work because this stream doesn't take character array. It takes integer array, string array, and stuff like that. Not a string array. I think it takes a different stuff. Let me see what all it takes. Okay, so it takes a double array, int array, long array, some object array, double array again, int array, long array, t array. Okay, so it takes all this stuff, but it doesn't take a character array, right? So what we'll do is we'll do the input dot chars. There is this chars which will create a. Why is this also showing error? Oh, input dot chars already creates a stream. I didn't know that. Is it a stream? I thought it was. Oh, it creates an int stream already. Fine. So it's even easier for us. It started a stream for us. Okay, so you got a stream of integers. Now you'll be confused. You are getting a stream of integers. How will you use it? Because we want a stream of characters. So the whole point is, in Java, everything is ASCII code, right? So if you guys are aware of ASCII codes, even I don't know the numbers, by heart or something. I think it's 52 is A, I guess. Okay, so each letter or character in a system is denoted by a number in ASCII. It's called ASCII. Okay, you can simply look up ASCII tables or something on Wikipedia. It will show you what is the respective number for each character. Okay, even an exclamatory or a question mark, whatever you do, there will be a respective number for it. Okay, so essentially what this chars or like an int string, what it gives us is, it gives us the ASCII equivalent of that character in the string. Okay, so let's say you have programming here, right? Programming is the string array. So it will give you a character string, maybe like what's 25, 75, 45. These are arbitrary numbers I'm writing. I don't know the actual numbers. Okay, so the stream will have integer array of these numbers, for example. Okay, so what we have to do now is you have to immediately convert this into a character. Okay, so what we can do is map, and what you'll do is for each item, so let's say ASCII value, I'm just writing ASCII as the thing, I'll convert it into character of ASCII. Okay, okay, so what I'm doing here is, in Java there is a shorthand which you can do. If you explicitly typecast it to a number to a character, it will simply give you the character value of that. Okay, now with this, what we can do is, let me write it in separate lines for better readability. Okay, so you mapped it. Now what you have to do, you have to deduplicate it, right? So let me do dot distinct. Okay, now you got deduplicated values. Now what you should do, you have to collect using the joining collector. So I said collectors, and then oops, this is where the issue is. Okay, I'll show you the issue. Collect, and then it says collectors dot joining, and then I say nothing. I mean, like, let me break it again. Okay, so this is showing an error. Okay, it says blah 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 blah. So what it is essentially saying is, this map is again returning an int stream. So from an int stream, it returned an int stream only. It didn't return a character stream or anything like that, right? If you see here, it returned an int stream. Okay, so how can we convert this int stream into a string stream? So map is actually intelligent enough to know that when you return something of string type or of an object type, that is the stream that it is looking for. For example, let's say I'm simply returning here, return hello, which is a string, right? Oh, sorry, I need not say return. Okay, if I say hello, oh, why is this not working? Okay, that was supposed to work. Let me try like this. No? Okay, maybe if I do new string of hello, that also doesn't work. Okay, that is weird. Oh, got it. So I have to say map to object. Map to object. Okay, this is the function. Okay, so when you say map to object, it will simply understand that it has to take whatever parameter is given here. Okay, so if I return a string, it will say create a stream of objects. So that stream of string it will create. If I, let's say, return an employee, it will return a stream of that employee and things like that. Now what you have to note here is we were returning a character of ASCII, right? But this character of ASCII, if you see hover and see here now, it returns a stream of character. But on character, there is no joining function. So if you see here, first of all, the collect is failing because on character stream that is not available. Okay, so what we have to do is we have to convert this character into a string. There could be other options or answers as well, but this was the most easiest way I could find. So you just do string dot value of and then pass the character inside. Okay, so what I'm doing essentially doing is I'm converting this character. So it went from how do I, let me show it here. So my pen is missing. Yeah, so it went from, let's say, P as a character to P as a string. Okay, so this is essentially what happened. So I mean, if you want to go one more level deeper, let's say the ASCII value of P was 75. Okay, it went from the number 75, the integer 75, into the character P. Okay, and then I am converting that character into a string double quotes P. Okay, so this is how strings are denoted in Java, right? So it's double quote P. So this is the whole chain that is happening in this function. So I'm taking the taking the string and converting it into an int stream, and I'm converting that int stream into a character, and that character I'm converting into a string. Okay, now I can pass it down the distinct function and then collect it as a collectors.joining, which will collect all the strings. I mean, join all the strings. Okay, so string result equals this, and I'll return the result. Okay, let's run the test case. Open call hierarchy. Two test cases are there. Let's run the first test case. Run as JUnit test. Okay, that passed. And let's run the second test case. Run as JUnit test. That also passed. Okay, with that we have completed level 3. Okay, there are much more levels to come. So there is level 4 and 5 as well. Okay, so while I'm talking about those things, if you guys have questions in this level 3, whatever we saw today, or since this is part 7, right? So if you have guys a question with part 6 also, you can ask. Okay, so for others, there is level 4 and level 5 are coming. There are 10 questions in each. We'll be solving that also. It will be more complicated than this, hopefully. Okay, so we'll see that also. And let me run the whole L3 test to make sure that every test passed. Okay, right, so all of the 10 tests in L3 have passed. Okay, so kudos to you guys for learning level 3. So when is the last stream session? I don't know. So if everything goes well, it will be 2 more days. So today is Monday, right? Tuesday, Wednesday. Wednesday will be the last stream session if everything goes well, because I'm doing 5 problems in a... Oh, sorry. So it's one... Okay, let me write it down here. Okay. So we just finished this one. Copy that. Okay. Font strike through. Okay. So part 8 will be level 4, 1 to 5. And part 9 will be level 4, 6 to 10. Okay. And and part 10 will be level 5, 1, 2, 5, and part 11. So there are 11 parts. Will be level 5, 6 to 10. So today we completed 7, right? So tomorrow it's Tuesday, Wednesday, Thursday, Friday. So this week we will complete the whole streams. Okay. So with that, streams will be completed. Now you might also ask what is it after streams. So I'm planning to do sessions on frequently asked interview Java interview questions and things like that, or we can go to Spring Boot even. So you guys drop in the comment what you guys would like to see. We will take that. Okay, fine. Any other questions, or shall we wrap up the session? Can you do 2 parts a day? I can, maybe. Actually, I finish office and come back home at like what, 7 o'clock or something. Then if I start a stream, it will be 7 to 9, because the stream is usually 2 hours. And then I have to have dinner and stuff. So 9 to 10, 10 to 11. Yeah, I can try. I'll try to do 2 streams a day, but I don't know how it will go. Something might come up in between. So if something like that happens, you'll have to bear with me. Okay. So yeah, that was that. Anything else? Oh, let me open this chat box. Oh, it's 11:10 already. Fine. Oh, I hope that's it. Hope you guys understood. Thanks for considering. Yeah, thank you. So hope you guys understood everything about stream so far. It was really interesting learning all this APIs, and what we are seeing is actually, I think we went through all the APIs of stream. Now it's kind of like, how do we use the streams API and the collections API together? That is what we are seeing in these newer problems. So yeah, let's see how level 4 and level 5 goes. So see you guys with a fresh mind tomorrow. Okay, thank you all. Have a nice night. See you guys tomorrow. Bye.